Hey guys, I wanted to go over the work with you guys. Let's see, for this week. So let's go over these practice problems. Okay, hopefully you guys can see this. All right, so I'm going to work them out here on the bottom for you guys. Let's see. All right, so let's look at the first problem, and I am going to use my pen here. All right, so if your goal here was to be able to look at this equation and determine what type of equation it is. The first thing that you see here is this square root symbol. So that should tell you that it is a radical equation, okay? And anytime you have a radical equation, we always want to get the radical by itself. So in this problem, it's already by itself. So then we want to get rid of the radical symbol. And so how do we get rid of square root? Well, we square it. And whatever you do to one side must be done to the other side, okay? So what happens when you square a square root? It just goes away, okay? So now we're left with 2t minus 1 equals 1 squared, which we know is 1. And now this is just a basic linear equation, and we can solve it like we know how to do. So we want to solve for 2t. So to get 2t by itself, we add the 1 to both sides, and therefore 2t equals 2. And then we must divide by 2 on both sides, and we end up with t equals 1. Now, as always, we should check your problem. So if you plug it back in, 2 times 1 is 2, minus 1 is 1. So the square root of 1 is that equal to 1. And yes, we know the square root of 1 is equal to 1. So that one works, okay? The next equation also has a radical symbol. So this one is also a radical equation. I'll write that really small over here. Okay, and the radical symbol is already by itself, so now all we need to do is square both sides. Okay, and so when you square a square root, it cancels it out, and so we're left with 3t plus 4 equals, now when you square a negative, it becomes a positive, because think of negative 6 times negative 6 is positive 36. And then we solve this just like a linear equation. I'm going to get the 3t by itself. So we subtract 4. And we get 3t equals 32. Okay. And then we divide by 3. We divide by 3. And we end up with t equals 32 over 3. And we're going to leave it like that. Okay, so now let's check our answer. All right, so I put 32 over 3 in the problem. Those will cancel. We end up with 36. The square root of 36. Is that equal to negative 6? Well, think about it. Square root of 6, square root of 36, okay? Can that equal to negative 6? Well, technically, there is a plus or minus symbol in front of this. So yes, it can be equal to a negative 6 as well, because negative 6 squared is the same thing as 36, okay? All right, the next one, you see a radical symbol in it. So we know this is a radical equation. Okay, I'm going to erase some of this stuff. I have a little bit more room. Okay, so this one's a radical equation, but this time your radical symbol is not by itself. So the first thing you want to do, you want to get this by itself. So we're going to have to add the 3 first. So you end up with the cube root of 1 minus 2x is equal to 3. All right, so now we want to get rid of the radical symbol. So this is the cube root. So instead of squaring this time, we're going to have to cube. Okay, because when you just have a regular square root, that means there's understood as a 2 right here, okay? So these will cancel. You're left with 1 minus 2x equals, and then 3 cubed is going to be 27. And now we solve this like linear. So we subtract 1, Negative 2x is equal to 26. Divide by negative 2, divide by negative 2, and you get x equals negative 13. Okay. All right, if we check this, the cube root of 1 minus 2 times negative 13 minus 3, is that equal to 0? All right, so 2 times negative 13 is going to give you negative 26, so this would end up being the cube root of 1 plus 26, and then minus 3. So that's the cube root 27. And then we know that the cube root of 27 is going to be 3. And we know that 3 minus 3 is 0. So we know this one works. Okay? All right, the next one is also a radical equation. And then this one's by itself, so we just need to do the fourth root this time. And so you end up with 5t minus 4 equals 3 to the 4th power, which would be 81. Then we add the 4. You get 5t equals 85. I'm sorry, it's kind of messy. And you end up with t equals 17. Okay. And then we plug this back in. So this will be 5 times 17, and then minus 4. That's going to be 81. And then let's check to see if this works. All right, so we want to do the fourth root of 81. So that means 4 numbers that are the same that multiply to give you 81. And yes, that would be 3. So that works. All right, again, we have another radical equation. Erase this. All right, this time though, we want to get rid of the 3. All right, so the next two are going to be the 2 more complicated. So I'm going to write these over here. Just give us a little bit of room. All right, so we end up with the square root of 3x plus 1 equals x minus 3. Okay, now I want to get rid of the radical symbol, so I need to square both sides. Square both sides. Okay, and so when you do that, that gets rid of it, and we're left with 3x plus 1 over here. Now, what does this mean? X minus 3 to the 2nd power. That means it's written 2 times. Okay, and now this is a polynomial times a polynomial, which means that you need to do the FOIL or the box method, and I'll go back over those with you. So FOIL, x times x first is x squared, outer, negative 3 times x is negative 3x, inner, negative 3 times x is negative 3x, and then your last, negative 3 times negative 3 is a positive 9. Okay? And hopefully your teachers have gone over this. Some of you might have done the box, but I'm pretty sure both of your teachers probably taught you, if you had either Mr. Price or Miss Green, you probably did FOIL. All right, so then we end up with this, and now this is a quadratic, and we know that we can solve a quadratic by factoring. You can use the quadratic formula. If they showed you how to use equation solver in your calculator, you can graph it. So let's see what we get. So we want to simplify this, and remember, for a quadratic, you always want to get it 0 equals something over here, okay? So that means I want to move this 3x over somehow, and I want to move the 1 over. Okay, so I end up with x squared. Remember, these two right here are going to be a minus 6x, and then I have a minus 3x because I moved that over. So that'll be minus 9x. And then plus 9 minus 1 is going to be plus 8. Okay, so I want to think about 2 numbers. If I'm going to factor this, which I think is going to be the easiest thing, 2 numbers that multiply to give you 8. But add to give you negative 9. So I know it's going to have to be 8 and 1, and they're both going to have to be negative. So negative 8 plus negative 1 is going to give you negative 9, and negative 8 times negative 1 is going to give you positive 8. So remember, it's always, if the coefficient is 1, you just look at the last term. 2 numbers that multiply to give you last term, but add to give you the middle term. So my factor will become x minus 8 times x minus 1 equals 0. And then we use the zero product property, and we set both of these equal to 0. So x minus 8 equals 0, and x minus 1 equals 0. And then we add the 8, and we add the 1. You get x equals 8, and x equals 1. And we want to check both of those, okay? So remember, this is our original equation. 3 plus the square root of 3 times 8 plus 1, is that equal to 8? All right, so that's going to be 24, 25. The square root of 25 we know is 5. 5 plus 3 is 8. So that one works. And then the other one we're checking is 1. So 3 plus the square root of 3 times 1 plus 1, is that equal to 1? That's going to be 4. The square root of 4 is 2. Plus 3, is that equal to 1? No. So this one will not work, and so our only answer here would be x equals 8. This is why we always have to check our answers. Okay? All right, let's do the next one. The next one is probably the most complicated one you'll see, but we need to go over it. I'm hoping this will help you guys when you get to this stuff in your other class. And some of you may already be doing it, but some of you may not be quite there yet. But hopefully this will help you, okay? All right, a radical equation again. And so this one, it's going to be hard to see that you can't just get them by itself. So what you have to do is you have to move one on each side. So what I'm going to do is I'm going to move this one over. So you end up with the square root of 3x plus 7 equals 1 minus the square root of x plus 2. Okay? And we're going to have to square these because it's the only way to get rid of the square root. So this becomes 3x plus 7, and now this becomes 1 minus the square root of x plus 2 times 1 minus the square root of x plus 2. And we're still going to have to FOIL this. And you might be wondering, okay, how do I do that? Well, same way. 1 times 1 is 1. 1 times negative x squared root of plus 2 is negative x plus 2. And then we do it again, negative square root of x plus 2. And then a negative times a negative gives you a positive. And if you have two of the same thing and you're multiplying, that means you're squaring these two. So what happens is the square root goes away and you're just left with the x plus 2. Okay, so now I end up with 3x plus 7 equals, now what do these combine to? Well, this is just like you have a variable here and you have a negative and a negative. Well, that's going to make two negatives, and then you just leave your radical the same, plus your x plus 2. Okay, all right, now I'm going to combine like terms over here. So I have a 1 and a 2, which is going to make 3, and then minus 2 square root of x plus 2 plus x equals 3x plus 7. All right, again, your goal is to get the radical by itself, so I'm going to move everything over so we can get this radical by itself. So I'm going to subtract the 3, and I'm going to subtract the x. That goes away, that goes away. 3x minus x is 2x plus 4 equals a negative 2 square root of x plus 2. All right, again, I want to get this by itself, so how can I get rid of this negative 2? Well, this is being multiplied, so what I'm going to do now is divide. And you'll end up with negative x minus 2 equals the square root of x plus 2. And now I can get rid of this radical by squaring this. I know this is a lot of work. Again, this is a problem that, it's a really difficult problem. So, all right, so we have negative x minus 2 times negative x minus 2 equals x plus 2, because remember when you square a radical, it gets rid of it, right? All right, and then we can FOIL. Negative x times negative x is a positive x squared. A negative times a negative gives you a positive 2x. A negative times a negative gives you a positive 2x. Negative 2 times negative 2 gives you a positive 4. Combine these, 4x plus 4 plus x squared. Again, how do I know what this is now? Well, there's a square here, so that means it's going to be a quadratic. And remember, to solve a quadratic, we must get it equal to 0. So what I'm going to do is move everything over. So I end up with 0 equals x squared plus 3x plus 2. And now this is an easy question to factor, okay? I want two numbers that multiply to give me 2, but add to give me 3, okay? So we know what that is. That's 2 and 1, 2 and 1. 2 plus 1 gives you 3, 2 times 1 gives you 2. So my factor is going to be x plus 2 times x plus 1 equals 0, and then I solve each, and you'll end up with x equals a negative 2, and x equals a negative 1. And of course, we have to check this. So plug it in. 3 times negative 2 plus 7, the square root of that, plus negative 2 plus 2 equals 1. Is that true? So that's going to be a negative 6 plus 7, that's the square root of 1, plus the square root of 0. Is that equal to 1? Well, square root of 1 is 1, square root of 0 is 0, so that one works. And then we try the negative 1, so that's going to be square root of 3 times negative 1 plus 7, plus negative 1 plus 2, is that equal to 1? That's negative 3, that's square root of 4, which is 2. That's going to be square root of 1 plus just 1. 1 plus 2, is that equal to 1? No. So that one does not work. We have one answer for that one. Okay, this seems to be taking forever, doesn't it, guys? All right, so now we are going to get down to some other type of problems. So these problems are where you're going to create a type of U substitution or a variable type substitution to put these into quadratic form, okay? So when you look at this, you think, okay, can I make this problem simpler? There's no GCF, I can't pull out, but I see that there's an x squared here, okay? And this is an x to the fourth. So when you see that, you think, okay, what if I let a u be x squared? And so what that means is if I let u be x squared, this technically would be the same thing as u squared, right? Because if I did x squared to the second power, wouldn't that be the same as x to the fourth? Yes. So then you would end up with minus 10u plus 24. And this is just a basic quadratic now, and we can solve that pretty easy. So how do I solve that? Well, I want two numbers that multiply to give you 24, but add to give you negative 10. And I'm thinking of 6 and 4, and they're both going to have to be negative. Okay, so I end up with u minus 6 and a u minus 4, and you solve and you end up getting u equals 6 and u equals 4. And then the last thing you have to do, guys, is you have to plug this, what you let it substitute in for, back in. So you end up with x squared equals a 6 and x squared equals a 4. And then you solve it, square root, so x is equal to a plus or minus square root of 6, square root, so x is equal to a plus or minus 2. And those would be your 4 answers. Okay? All right. The next one, same process. X to the 6 plus 7x cubed minus 8 equals 0. If I looked at this and I said, okay, what if u is x cubed? Can I rewrite this as u squared? Because look, x cubed squared, isn't that the same thing as x to the 6? Remember, laws of exponents, you multiply? Yes. So what I'm going to do is I'm going to let u be equal to x cubed. So u squared plus 7u minus 8 equals 0. And then I'm going to factor this, and I know the factor is going to be u plus 8 and u minus 1. 8 times negative 1 gives you negative 8. 8 minus 1 is 7. All right, so you know u equals negative 8 and a u equals 1. Okay, and then we substitute back in x cubed equals negative 8, x cubed equals 1. How do I get rid of a cube? You cube root it. Okay. And let's see, what would the cube root negative 8 be? Okay, that's going to give you a negative 2. And what's the cube root of 1? That's going to give you a 1, right? All right, same thing for this last one. Notice here you've got the same thing here and here, okay? And you're going to want to move this 3 over to get it equal to a 0. Because remember, quadratics, you always want to equal to 0. So we end up with 2s plus 1 squared minus 5s plus 1 minus 3 equals 0. Okay? Erase all this stuff right here for you. Oh, we're almost done. And so then what I'm going to do, I'm going to let u be s plus 1. So you end up with 2u squared minus 5u minus 3 equals 0. And we can factor this. Negative 3 times negative 2. We want two numbers that multiply to give you negative 6, but add to give you negative 5. All right, so that's going to have to be what? Negative 6 and 1. Negative 6 plus 1. Okay, so that means this is going to break up into a negative 6u and a 1u. And then you can group or use the reverse box, whatever you guys were taught. I'm going to go up here. I'm running out of room. And I'm going to group 2u squared minus 6u. Group those. And then your 1u minus 3. What do these have in common? A 2u. I bring out a u minus 3. And then bring out a 1. And I get u minus 3. These are the same, so my factor becomes 2u plus 1 times u minus 3 equals 0. Solve. 2u plus 1 equals 0, u minus 3 equals 0, u equals 3, and u equals negative 1/2. And then what's the last thing you have to do? You have to replace what we substituted here back in. So s plus 1 equals negative 1/2. S plus 1 equals 3. S is equal to 2 because we move the 1 over. And move the 1 over. S equals negative 1.5. All right. Let's see here. And please email me if you guys have any questions on this. I can set up a Zoom meeting or anything to work with you guys. All right, so this one I'm going to move the x over. And we end up with negative 4 square root of x equals negative x. And then I'm going to just go ahead and square this to get rid of. Okay, so we end up with x squared equals, so this is really negative 4 square root of x times negative 4 square root of x. That's what's going to be 16 x, right? Okay, because the square root of x times the square root of x is going to give you square root of x squared, which is an x. And negative 4 times negative 4 gives you 16. Okay, this is a quadratic again now because there's an x squared, so I'm going to need to move this over. And so you get 0 equals x squared minus 16x, and I can factor this. What are two numbers that multiply to give me, what are the GCF of this? And that's going to be x. So you end up with x minus 16. And we factor these, you end up with x equals 0 and x equals 16. And those would be your two answers for that one. And then the last one is another huge substitution one. So notice here, could I let t to the 1/4 equal u? Well, if I did t to the 1/4 and I squared it, what would that give you? Well, that would be t to the 2/4, because remember we multiply these, which is the same thing as t to the 1/2. So yes, I would be able to do that. So let me erase some stuff. So I'm going to let u be equal to t to the 1/4. Therefore, u squared minus 2 times u plus 1 is our problem now. And I can easily see that I can factor this. What are two numbers that multiply to give you 1 but add to give you negative 2? Well, it's going to have to be a 1 and a 1. It's going to have to be negative, right? So you end up with u minus 1 equals 0. And you're end up with u minus 1 equals 0 2 times, which is the same thing. So end up with u equals 1. And then the last thing you do is have to substitute this back in for u, so that's t to the 1/4 equals 1. And then how can you get rid of 1/4, okay? Well, this, I don't know if you guys know, but if you convert this back to a radical, this is the same thing as the 4th root of t, because there's a power of 1 here. So if you fourth it on both sides, it's like saying if I fourth this, right, that would be 4 times 1/4, which becomes a 1. So that's what you have to do. So you end up with t equals 1 still as the answer. Okay, I know these are really difficult problems, but I wanted to go back over them because you guys will be covering this in your math class, and these are the most difficult ones that you'll see. Please email me or contact me if you guys need some extra help. I'll be happy to set up a Zoom meeting, or if you guys want to come in, okay? And that's it.